Mute live. Hello, good morning all participants. Welcome to the first digital manufacturing live meeting. A new approach for these presentation sessions. Happy where you can learn, listen, and actively participate. Be patient with us when some things are not perfect, because it's the first time. Today, sheet metal is on the agenda as a manufacturing process. Matthijs Cox from metaal will explain the further details of this process. Matthijs, can you introduce yourself?
I surely can. Good morning, everybody. As Arno said, my name is Matthijs Cox. I'm from metaal. First, we're going to show you what the presentation of today will be about. We're going to welcome you. We're doing that already. We're going to tell you why should you use sheet metal. Then I'm going to tell you something about the core processes of metaal. I thought it would be nice if I took you on a virtual tour of our factory. That seemed a bit challenging this morning because I made a lot of movies and they're experiencing some lag, but I'm curious what you guys think of it. Then we're gonna ask you to participate in the meeting. We're gonna show some questions. You can answer them, and we would like to for you to actively involve in the presentation. We're gonna have a short break, and then we're gonna move on to the engineering part. My colleague Stefan van Beers will do that part of the presentation, and then for the closing, we're gonna have some Q&A, so you guys can ask some questions. Yeah, as I told you a minute ago, we would like you to take active part in the presentation. So keep your phones at hand. We're going to have some interaction there, and feel free to write down your questions and ask them in the chat later. I will explain more about the solutions that we offer in sheet metal. I'm going to tell you who is metaal, why you should use sheet metal, which processes that are needed to produce sheet metal parts, and what are the limits. So starting with who is metaal. I'm going to show you in the next two slides. The first one, we have an overview of how our client base is divided. On the left top corner, you see that the biggest part of our clients are OEMers, original equipment manufacturers, then system suppliers, a little bit construction, and some other markets. Moving to the right, you see our core processes at metaal, engineering, laser parts, assemblies or samenstellingen zoals het hier stands, and finishing. Starting with engineering, we do mostly co-engineering. So our clients have an idea of what they want. They have a sketch, they have a first drawing, and we try to do all the smart things that we know with sheet metal or tubing, mainly based on laser cutting, and try to put in some value that way. At laser parts, we laser cut the base parts, the products. At assembly, we do the bending, the preparation before welding and bending, and the final assembly of the parts. And at finish, we do the finishing of stainless steel products. That's glass bead blasting, ceramic blasting, and we do the cleaning of the products there. We can clean from grade 4 to grade 2. So grade 2 surface, that's the highest grade that we can offer. So our product mix is really low volume, high mix. You see it more and more in our markets. The number of orders, the order numbers, the number of pieces to make is declining, and the difficulty of products is growing. So yeah, that's something we have to deal with. Then lower you see our revenues over the past couple of years. Not as big as ASML's, unfortunately, but for us it's good. The build-up of the people working at ASML, at Box Metaal, mostly it's a man's world still, only 5% female. We also have some females working on the workplace, so that's nice to have, I think. And we'll try to encourage it, but it's not that challenging, not that good for women, I think. Then the next slide. Box Metaal processes mainly stainless steel. 95% of the material that we process is stainless steel. The most common sorts that we use are 304 and 316, of which the 316 material is more corrosion resistant. That's because of the way the material is built up. It has some more molybdenum, and that's why the corrosion resistance is higher. Both of the materials are non-magnetic. There are magnetic stainless steel sorts, but that's more in the 430 series. Those materials have a higher grade of carbon in it, and that's why they are magnetic. The base plates that we use at Box Metaal are different sizes. We can use from 4 to 2 meters to 1 to 1 meters. And that's the base plates that we lay the products in, so we try to make the most optimal nesting in the product to get the most parts from one base plate. The thickness that we can use is range from 1 to 30 millimeters. And I have to say that 30 millimeters we don't use that often. The most we use is 1 to 4 millimeters. Then moving on. So why should you use sheet metal? What's the benefit? In comparison to machine parts, so turning and milling, the price of a sheet metal part is lower. The freedom in designing, if you use laser cutting technology, is you have a lot of freedom to design shapes and forms. It's a relatively thin material, so if you have weight issues, the sheet metal often offers an opportunity. If good designed, if you design it smartly, it's very quick to produce. So laser cutting takes not a lot of time. And the stiffness can be achieved if you use bending smartly. So if you bend the sheet metal, you can get a very stiff, longer part. So this is the next sheet. We're going to ask you guys to actively take part. So if you would like to scan the QR code or go to the website and put in the code presented, then I would like you guys to answer the question, what is the most important reason you think to use sheet metal? And we're going to display the answers now. So I hope you guys are participating. We don't see any answers yet.
ook in de chat de link gezet.
Okay. Still waiting, but hopefully it's working.
Code.
The code, I'm going to put him back in. Yeah. Someone asked for the code. Very good thinking. It's 314103. So 314103.
Okay. We hebben nog geen.
Still no results. So maybe we can come back later. Now we're gonna see. Maybe we come back later if you guys want. Then just participate. We would like you to do because we like a nice interactive presentation.
Yeah.
So we're gonna move on. The next sheet. Which processes are needed for making sheet metal? I'm going to talk about. Oh yes, I heard from Wim, our producer.
Okay.
We have. Nice to see you guys are filling in a lot of things. I see cost. Cost is mainly the low weight. Versatile, yes, all very good. Yes, very good reasons. Yeah, so I think you guys understand the reason why. Thank you very much, and sorry for the long time it took.
Okay, let's go back to the slides.
We're gonna move on.
Yeah.
So which processes are needed? I'm going to talk about laser cutting, and as I told you guys, it would seem cool to me if I could take you on a virtual tour of our factory. So all these processes I'm going to show to you in a video, and I'm going to talk through the video to explain what we're seeing. So I'm going to start with laser cutting in general. That's not a video, but the next one is. Laser cutting of sheet metal and deburring, then laser cutting of tube. Then I'm going to show you the preparation we do before bending and welding. Then the bending of sheet metal. The next film will be welding of sheet metal and tube and some smart things we try to do there. And then something about the after treatment. So that's the glass bead blasting and ceramic blasting. And finally the cleaning. So the first video is going to start. I hope.
Yes, the sheet.
First, the sheets. I'm sorry. Yes, the laser cutting in general. So to the right, you see the laser head. As you see, the laser beam is transported via a mirror to the nozzle. There the laser beam is concentrated to a width of 0.2 millimeters, and with that concentrated laser beam we can cut a workpiece or a product out of a base plate. The product can have all types of different shapes and sizes. So that's how the laser cutting works. We have two types of lasers at Box Metaal. That's the CO2 laser, and we use it for thicker materials. And we have the fiber laser that we use for thinner materials, and we can use it for different types of material. For example, copper we can cut with a fiber laser, but we can't cut it with a CO2 laser. The speeds of the laser range between 0.5 and 10 meters per minute, where the fiber laser is the fastest of the two in the thinner sheets. The tolerance that we use at Box Metaal is the ISO 9013, where the smaller measurements have a higher tolerance than the greater measurements. So the longer the piece, the higher the tolerance will be. In general, we use a tolerance on laser cutting of 0.2 millimeters. So now we're going to go to the first video, and that's the one of laser cutting sheet metal and deburring. Hopefully you guys can see it good. Here we see the laser cutting factory of Metaal. If you can pause it a bit, yes. The blue pellets you see, that are that's the stock of base material that we have. We have a lot in stock because we have to respond quickly to the questions of our customers. Here we see the laser cutter. That's the CO2 laser that we see. Here you see the head of the laser that I talked about. The rough area that you see in the film, that's the bed that the base plate is laid on. And this explains why we always have a good side on the plate and a lesser side. So the lower side of the plate always get a little bit damage from the bed it's laid on. If we cut products that are used for grade 2, we use a special bed that's filled with aluminum rings. So the base plate does not get scratched or gets yeah, how do you say it? Damaged. Yes, thank you. Yeah, move on, please. Now you see the laser cutter, it's cutting out the products. And if you just freeze here, yes, very nice. You see that the big, the sparks on the other side. As I told you, the laser beam is concentrated to a width of 0.2 millimeters. And then with 2 types of gas, we can choose between 2 types of gas. So that's oxygen and nitrogen. We can blow under high pressure. We blow the molten material out of between the sheets. So that's what you see here. That's what the big spray is coming from. So now we're moving on to look at how the program is made, how the machine is running its program. So if you could freeze here, thank you. This is the machine running its program. You see the red parts that have already been cut. The blue parts are still waiting to be cut. The machine makes, the software makes an optimum nesting from the parts that we put in. So he determines on the shapes and the sizes of the product how many we can get out of one base plate, and then it makes the most optimal nesting. Here you see the machine, the little dot, that's the laser head moving. So there you see how far he is. So here, yeah, a little bit further, please. Yeah, thank you. Yes. Here you see a loading and unloading station. So I talked about the blue pellets that we use during daytime. So during daytime we cut smaller plants. So in nighttime we use the loading and unloading tower that you see here for keeping the machine going when we at night. The machine unloads itself and it puts the plates on the white pellets that you see, and then it goes into the tower, and the next morning we can get them out and sort them. You see the cut products that are waiting to be sorted. The tower again. And here you see some rest material waiting to be scrapped. Now we're going to the deburring process. Here you see one of the plates being deburred in the machines that we use for that process. And yeah, pause a bit. Here you see that in front, yeah, you can't see it in this picture, but in front there's a grinding sheet. The grinding sheet gets off the most rough edges of the plate. and then these two brushes, they make a nice round edge. So if you get your product, then it will be hand friendly. You don't have any sharp edges anymore, and it can be used in further processes. Here you see the product being deburred and the edges being rounded. So it's just a bit filming that we did on the job. As you see, it's not a professional movie. Here the product is coming out of the machine, and here you see the nice round edges. All the damage is done. It's gone, I think. Okay, thank you. And then to the next film. Right. How's it? The rest are all clips.
Okay.
The next one will be about the laser cutting of tube. So here it goes. Now, here we see the stock that we have of tubes. Also a lot of stock. They come in bundles, the tubes. And that's also one of the reasons that we that's a bit challenging when we're cutting tube, because the tubes are a bulk product. They're fabricated in great numbers. Then the tolerances of the tube are very, very high. Or low, I don't know how to explain it, but the geometry of the tube can vary. And it can vary so much that the tube is less accurate than our laser is. So we can only be as accurate as the tube is. And that's a challenge that we have to face every day. Here you see the machine loading one profile. In this case, an angular profile. So if this profile would be a little bit bent, then it influences the tolerance on the end product. And there's nothing we can do about that. Here the profile is loaded into the machine. So the machine is going to do a measurement of the profile. And that's done. Yes. Here the machine is measuring the profile, the length of the profile, so we know exactly how long it is. And now you can see the profile is going to be loaded into a gripper. And the gripper, that's the reason why we can't cut a full profile. The profiles that we use are 6 meters. But we only can use 5.8 meters because we have to hold the profile in the end. So now you're going to see the cutting of the profile. You have 2 angular cuts, and it can be anything that you think of. We can cut into a tube, and then the product is already finished. So now we can go to the next clip. So that's the cutting of tube. Now I want to show you guys some more. We're going to take the next step in our factory, and that's the preparation before bending and welding. So the sound. In practice, you see that the preparation that we do for bending and welding is, wait a minute. Okay, could you pause for a bit? The preparation that we do for bending and welding is a lot of handwork, because how I explained to you earlier that the product flow is very low volume, high mix. So for these type of plates, maybe I only make 3 of these plates. It's not economically valid or affordable to make a CNC program and to do it, how do you say it, on a machine. So it's a lot of manual work. So here you see the cutting of thread done manually. Now we're going to see a countersunk hole that's going to be made also manually. And if this would be a larger number of products, then we would do it on a CNC machine. It would go automatically. Here we go to the inserting of a threaded bush. So here you see the bush being inserted in the plate, in the product. So there's all types of size and shapes and sizes of bushes. You guys know, I think you know about it. So this is the machinery that we use for this process. And here you see the welding of a welding stud. We have a mold plate that we can keep the welding stud in place, and then it's fixed to the plate. So these are typical processes that need to be done just before the bending and the welding. So moving on to the next slide, and that's the bending of sheet metal. I'm going to start with the overview of our factory. So, and for this part, I will need a lot of pausing. If you could pause. Thank you. What I would like to show you guys is the difficulty that we face when bending plates. Here you see the upper part of the tool and the lower part of the tool. The lower part has a V-groove, and the size of that V-groove, that's determined by the thickness of the sheet. The upper part has to push the material with enough pressure to achieve the angle that we want. The pressure needed to achieve the angle is influenced by the thickness of the material, the sort of the material, and the length of the plate that you want to bend. The V-groove, the size of the V-groove, that determines the smallest bend you can make. So if I take a thicker plate, I need a bigger V-groove, and then I can only make as small as a bend as the V-groove allows me to. Yeah. So here you see the bend being made, and here the bend is done. Yeah. As you can see here, the height of the bend, it's determined by the V-groove, but also the holes in the plate, they have to be far enough from the bend, because if they are too close to the bend, the holes will deform. That's something that we see every day, that designers and engineers put the holes too closely to the bend, and then the holes will deform because the sheet will be pulled into the bend. Here we see another product that needs to be bent. Everything at Box Metaal on the bending department is done offline. So all the programs are made in our engineering department. None of the programs are made at the machine. And here we see a big plate being bent. Here the guys have some help from the machine. We have two bending helps that lift the plate. So when we have to bend big plates, the bending is done accurately and the guys have some help. Now here we have something that that's new at Box Metaal. We invested in a Dynacell, and that's a robot combined with a bending machine. We use it for types of work that don't fit the people that work at Box Metaal. The people working at Box Metaal are all craftsmen, and they like to do daily what they're good at. So they like to think about how they can make difficult products, and they don't like to make easy products in high numbers. So that is where the Dynacell comes in. He can make the easier products that we make in higher numbers, and we put them on this machine so our craftsman can focus on the task at hand, and that's the difficult parts. It's also programmed offline completely. Here we see another help of the men working with the machines. This is a tool cell bending machine, also programmed offline, and it builds up its own tooling. So the tooling is taken from a magazine at the end of the machine and is built up according to the program made. Here we see the program that's running, and we see that the machine is building up the tool set just as programmed. So years ago we had to do it by hand, and now it's all done by the machine. So moving on to the next step, the welding of sheet metal and tubes. So after the bending, the parts go to our welding department, and there they are assembled to end products. So let's wait on the film to start. Go back a bit to like the sound. Okay, so here we see the bent parts, and we see the plates already prepared for the end result. And here is parts that we all had, the drawing that we all know from a client that we all know, I have to say. And here we see the welding, just a bit more, yes. Here we see the one of the two welding processes that I want to show you, and this is TIG welding. It's tungsten inert gas welding. And the way this process works is we have a torch, and in that torch is a tungsten rod, and the tungsten rod makes pulls an arc between the workpiece and the rod itself. So that arc is hot enough to melt the material, and the welder in this case has the freedom or the opportunity to choose if he wants to add material or not. So he can weld just two plates together, just melt them together, or he can choose to make a stronger, bigger weld by adding a stainless steel rod and making, in that case, making a bigger weld. So here we see just melting two plates together, and on the outside here we see another process. So this torch you see has a thread coming out of it, and that's the MIG process. This process is used often for thicker sheets, and the welder does not have the freedom or the option to add a material or not. It just does. So the thread comes out of the machine, and by coming out of the machine, arc is formed, and the thread is put into the weld, so we get a much thicker and stronger weld. So it's oftenly for thicker sheets. Yeah. So here we see the welding start, and you see the thread coming out. You see the sparking, that's the thread coming to the plate. So that's the weld. So this is for, it gives a much thicker weld. So here you have an overview of our welding department. As you see, we're very busy. You see products waiting to be finished. You see plates bended and waited to be assembled. You see the workplaces of our welders. Here you see a product being assembled. So all types of positions we need to weld in. And here you see tubing that's waiting to be welded. And as you can see, we have a male and female connection in this tube. That's with our tube laser. So we do that in order to get a real accurate measurement between two parts. So we provide one part with the female side and one part with the male side, and we can put those two together, and then, as you can see, they fit perfectly, and then the measurement from the one part to the other part will be very, very accurate, up to I think 0.3 millimeters. Here you see the principle of our table. So we put in, we put in this types of tools. Our tables have a lot of holes in them, and maybe you ask yourself why are there all those holes in the table? Now they're for putting on tools on the table. The tools have a very flat and angular side. We can use it to make good and straight products. So that's the welding at Bosch Metaal. Now moving on to the next one, and that's the after treatment of stainless steel. I hope you guys enjoy this virtual tour of a factory. Oh, this is the first video. Maybe we wait for the sixth. Yeah, that's the one. So here we're gonna go to another firm of Bosch Metaal Group, and it's average finish. Just wait to buffer the movie a bit so we don't have lagging. Okay. We still have lagging. Okay, now it's go. Just pause here. Yeah, thank you. At average finish, we do the glass bead and ceramic blasting, and we do that in order to make a nice and equal surface on the products. So as you see here, the products are waiting to be glass bead blasted, and they still have the discoloration of the welds. So, and you see the surface of the tube, it's not evenly. So we're gonna make that nice and even in the blasting chamber that we're gonna see in a bit. So here you see a guy blasting plates. You see the guy moving around with the blasting device, and that's because he has to make sure that the pressure that he applies is evenly spread over the plate. If he doesn't do that, the plate will deform completely, and yeah, you have a bad product. The movement that he makes has to be equal on both sides. So if you do it on one side, you have to do it exactly the same on the other side to make sure that your product comes out nice and straight. So here you see him swirling around to even the pressure. So here we see a finished product. Here you see all the welds everywhere. The discoloration was, it's completely gone. The surface is nice and equal. So this is the end result after the blasting process. Something else we do at average finish is grinding. We grind for aesthetic reasons, but also for providing the surface with a predetermined roughness. So if you want the surface to have a roughness of, let's say, 0.2 Ra, then we can make sure that the surface is exactly that roughness. We can also supply a measurement with that. And yeah, in practice, it's a lot of manual labor because all the products have different shapes and sizes. Sorry, and there's not machinery that's equipped for that. So here we see the manual part of and here we see a robot, and that only is used for I think 5 types of product that are all programmed in, and we do a lot of numbers in. So also here at FVS Finish, we try to take advantage is not a good word, but we like to have our people to excel in their craftsmanship, and the machine has to do the numbing work. Here we see another thing we do at FVS Finish called etching. We have a film. We go over it with etching machinery, and then we have a nice print of a text or a logo. In this case, both. So we have a nice finished product here. Okay, then the final step in our process, that's the cleaning, and that's done only for ASML. So we also have a lot of clients that deliver to you, so the second tiers, and they come to us to do the cleaning of their products, and it's done by FVS Clean. So here you see the cleaning baths, the ultrasound chambers. Here you see some products packed and ready for final inspection. So in the double bag. Here we go to, here we see the new machine of FVS Clean. And here we go to the, how do you say, the clean room. The small flow chamber you see, that's used for packaging small stuff, so smaller parts. And then here the bigger clean room. It's not as big as you guys have, but for us it's good enough. We use for making end assemblies and also for packing larger products. So she's happy to be on the film, you see. Here we see the newer machine at FVS Clean, and it's a machine to do the grade 2 surface cleaning process. So the products are put into the bin, and here you see the basket or the bin in the machine. All types of chemicals are sprayed on the products. The bin will be turning, and in that way the surface will be very clean, up to grade 2 surface cleaning. So it's not vacuum cleaning, but it's grade 2 surface. Here we see the large container for the chemical liquids. And here the other side of the machine also containing liquids to do the cleaning. And here we see the conveyor on which the clean products go into our clean room, and from there on over it's taken by the people working in the clean room, and they use it to package it in the correct way. So that's the final process in our factory. So I hope you enjoyed this way of presenting. The thinking about it was to take you on a virtual tour, to show you what we do daily, and I hope we've achieved that. Now the next sheet before we go to a break. Now it's because these are all the.
Oh, these are the photos.
Yes. Then we have this one.
Ah,
Yes.
okay. Yeah.
Yes. Thank you. So I hope you now have a better understanding of the possibilities of the techniques we use. I explained a little bit of the challenges that we face, and here also we like you to go to the chat and let us know what challenges do you see, and maybe we can converse about it in a couple of minutes. So thank you very much, and thank you for listening. We're back online, and you guys have posted a lot of questions, so thank you for that. Now we're going to go on a 10-minute break, and in those 10 minutes I'm going to read the questions, and the answers will come later on in the presentation. So see you in 10 minutes. Thank you. Snel die tijd.
Mute, ja.
So I see the 10 minutes coffee break is up. So I hope you guys enjoyed your coffee or tea or whatever you were drinking. It's good to see that you ask a lot of questions. So I don't have time to answer them all in this moment, but I'm gonna choose a few, answer them now, and the rest I will answer via mail. Let's see. One from Floris Zoethout. You work in 95% of the cases on stainless steel. Are these machines bending, cutting, etc. for stainless steel only, or do you have separate machines for steel and aluminium? That's a good question. We don't have separate machines for steel and aluminium, but we have separate tools. So the parts on the machine that come in contact with the material, those are interchangeable, and we only use, for example, on the cutting machine, we have special beds for stainless steel, and we have special beds for carbon steel. So that way we don't have, how do you call it, infectation or that rust forming on the stainless steel. Another question from Baba Samana. Isn't the sheet metal fixed during laser cutting? No, the sheet metal is the sheet metal sheet. The base plate is laid on the laser bed, and we measure the corners so that we exactly know the orientation of the plate, and then the outer rim of, let's say, 10 millimeters is not used for the products, and in that way we are sure that we use the products in the right direction, and the orientation of the products is good. So we don't have to fix the plate because yeah, the plate stays nearly still. And then we have a question from Jelte van Manen. What are the disadvantages of glass bead blasting over pickling and passivating of welded assemblies, or do they both serve a different purpose? It's the second part, that's the truth. They both serve a different purpose. The pickling and passivating is done to clean the product. So stainless steel is stainless because of an invisible layer that's on the material. That layer will be damaged during work process. The stainless steel has self-healing properties. So if you passivate it, that's what passivating is, the invisible film will heal again, and the material is stainless again. But to make sure that there are no faults on the material, then you put it in a pickling bath, and that way you make sure that all the material is clean, and afterwards you passivate it, so everywhere the layer is put back on the material, and the whole of your product is stainless again. So the rest of the questions I will ask via the mail. Thank you for all the questions. It's good to see that you take part in the presentation. And now I will give the word to my colleague Stefan van Beers. He's going to tell us more about the engineering at Box Metaal.
Hi guys, welcome back everybody. I hope you're doing well on the other side of this internet line. I am Stefan van Beers. This week working for 21 years at Box Metaal. I started in the factory, a little bit welding, and I started engineering from scratch. And currently I am responsible for engineering and IT at Box Metaal. I am hosting this part of the presentation, and here the main question is, how can we cooperate to innovate? So we have here the 6 subjects you see, and a real example in the end of the sheet, and that's a case that's also delivered to ASML as a product. The first subject is co-engineering. At Baxmetal, we want to help our customers with technical questions or challenges. Sometimes we just give you a good direction to proceed in your own design process. Best case, like the example you see later, is for you to provide us a base 3D file or a space plane file, and with all the necessary geometry and the info, so we can work together and get to the best product the fastest way. That's the next step to collaboration in the design process with customers. Communication in an early stage in the design process with suppliers like Baxmetal is very important. Communication can be done by mail with a short explanation and the base 3D file, or in a team session. It's best for the supplier to can understand the challenges that you face, or even prevent challenges that may come later in manufacturing. Also, the right choice of the base material of the product is very important, especially with aluminum in combination with bending. We see a lot of cases that a hard aluminum is chosen, and then it breaks during bending. The harder aluminum is perfect for milling, but not for sheet metal bending. So the choice of material and the collaboration and the communication, it can save you a lot of time from design and from design to end delivery. The third one is if tolerance is allowed, sheet metal is great value for money. In many cases, sheet metal only is perfect for your needs. Maybe in combination with milling at the end to get the right tolerances can be a step. But if you have the choice and if you have the chance, sheet metal only can be a perfect solution. But thinking without tubes or milling or unnecessary welding gives you the best value for money. The fourth is laser cutting and bending are overruled by too narrow tolerances. Like Matthijs said in the beginning of his presentation, with the laser cutting, tolerance ISO 9013 begins at the start of the manufacturing process. We at Baxmetal see a lot of drawings or GT files that are filled with a lot of tolerances. And sometimes if you ask the engineer or the person that orders the products, what are the demands of the product? And most of the times it has too many and too narrow tolerances. So it's basically not suitable for just only sheet metal laser cutting and bending. That's a waste of time and money. The fifth is the foolproof male-female connection. You saw in the previous movie at the welding department that Matthijs showed 2 parts that were connected with a male and female connection. This is a way, perfect way to position the parts in an accurate way. You can even go a step further and design the male and female connection that is only can be connected in one way. It saves a lot of time, thinking time for the welder, and also quality rejects that your parts are positioned only the right way the first time. The sixth one, that's the offline CAM programming. If the 3D data, so the step file, is first time right, then it can be processed in our software. So collaboration and communication at the beginning can save a lot of communication during programming that the software says is not bendable or not, not suitable for bending. So at this moment, PMA data is not automatically used in our CAM software. For sheet metal and tube, it's in the near future. So not at this moment. Here you see the end conclusion. The biggest win is when supplier and customer really work together, and really is also at the right time. So not afterwards, but if it's needed, at the beginning. So now here you see an example coming. At the left there you see an example of we did real time. So there was a design, a base model, and there are some questions. How can we make it? It's communicated at first. So what options do we have? Now then we came with an advice, and the advice was in this case for small welding. The start of the product was 0.5 millimeters thick, and we give the advice to change it to 1 millimeter if it suits the space claim, and we give you a direction what to bend and what not to bend. So it's the first time right, and you see that from the beginning of the collaboration till the end of the products are delivered is a duration of 2 weeks. So that's very nice. So you can see a simple product, or it looks like a simple product. It also looks like a big product, but it's only 15 millimeters in diameter or in volume. So it's very small, and this is a nice example of how you can work fast together and use the strength of each other. So this was my part of the presentation. Stay safe and have a nice weekend. And I give it back to Arno now.
Hello everybody, back almost to the end of the presentation. I hope you enjoyed and learned a lot. And what we ask now is, can you actively fill in MS Forms with a sort of quiz, and you can win a booklet of geometric tolerances and measuring examples. So we hope we have enjoyed you, and you can also do the last step with us. Wim is putting it in the chat, so you can find it in the chat, the link. You also can find the link afterwards in the presentation, or scan the QR code. I hope you all fill it in, and the first 5 we can give a real booklet to use. It's a handy tool. You also can find it in Dutch and English on in the end on the link of the presentation. So then you can have it digitally. So where you can find some things back, you can go to the manufacturing knowledge sharing site, where we come up with a direct link to the knowledge sharing center platform, where we bundled all the information of this presentation, and you can find everything back, the videos, the presentation, the questions and answers. So we really hoped we enjoyed you a lot of time, and we will go up to the next presentation. Yeah, here I put all the links together, what you can find where in the presentation. So yeah, I thank you for joining, and hopefully we see you back next time.